Good morning, everyone. Today we are going to discuss about one of the most important data structures, that is linked list. Okay, so so what are linked lists? Actually, linked list. The name itself suggests that it is going to contain some links which is specified in its name, and list is nothing but a series of elements. So let's see the definition. A linked list is an ordered collection of data in which each element, or which is called node, contains minimum two values, that they are nothing but data and links to its successor and or predecessor. So based on this successor or predecessor, again there will be different kinds of linked lists and types of linked lists. So the basic thing of linked list is it is a collection of data where an order is maintained. It is not an unordered collection, it is an ordered collection. That means after this element is going to come, after this element is going to come. And how they are represented? In the form of nodes. And that node will contain two things. One is data and the other one is link. See, in a linked list, before adding any element to the list, a memory space for that node must be allocated. So here what we are doing is, we will first allocate memory location only for one list or one node or two nodes or three nodes, whatever uh, data which you have at your hand, and the memory is allocated dynamically as and when needed. So that is the beauty of your linked list. There is no need of allocating the memory prior or before running the program itself at compile time itself, which is the drawback of the arrays. Arrays have the drawback of allocating the memory in the program itself or at the compile times. So they are not dynamically allocated. See here, each node of the linked list has at least, minimum, it has to contain two elements. First one is the data member being stored in the list, or the element, the data, actual data which are storing in the element. They can be names or numbers or whatever they are. The element, the data which you are storing in that node, and the second part contains a pointer or link to the next element in the list. Why? Because here the nodes are not stored together. They are stored as in when they are required. When they are allocated the memory. See, at the starting of a program, I need only two nodes. So I have created two nodes. In the middle, I may ask for other nodes. And at that time, you have to allocate. So these will not be together. These are placed somewhere else in the memory and these are placed somewhere else in the memory. But again, you have to link these two nodes to each other. So that is the reason we have to maintain a pointer or link to the next element in the list. So let's see how these just actually. So this is what a linked list is, and this is what a node is. Actually, your linked list is made of these kind of nodes, and minimum, I said a linked list would contain two parts. First one is element and the other one is link. Element is nothing but the actual data or data member, and the second one is pointer or link. Fine. And how do you indicate that the linked list has come to an end? By putting a -1 or null pointer or null value or -1 value in this link portion, which indicates that your linked list has come to an end, or it is the end or tail of the list. When elements are added to a list, memory of a node is dynamically allocated. This is what I have observed in the earlier points. When and as and when you need the memory for the node, it is allocated. No need of allocating it prior hand or beforehand. It can be allocated as you request it. Next, the number of elements that may be added to a list is limited only by the amount of memory available. So that is what is the one more advantage of your linked list. So no need to, I mean, as you're not specifying the size, there is no limit. So the number of elements that can be stored is limited only on the memory. So if you have a large amount of memory, till the memory is gets full, you can store your data. Generally, we don't build that much data into the memory, but this suggests that there is no limit, and it is limited only by the size of the memory you have. Next, so before going, I mean, before we further discuss about how a linked list is created or what are the operations that you perform on a linked list, first we have to try to understand what sequential organization is and what linear organization is. Actually, arrays and linked lists both are examples of linear lists of arrangement. Linear list arrangement, that means the data elements are arranged in a linear format. They're not arranged in a random way. They're arranged in a linear. But in that organization also, you can put arrays into sequential organization and linked list into linear organization. What are the features of, how do you define sequential organization, or what are the things that you do in sequential organization, and what are the things which you do in linear organization, and where comes the difference, which is we are going to discuss. Once you understand this, then only we can move further and completely get understand the knowledge what linked list is and how it works. So what sequential organization is? So the features are successive elements of a list are stored a fixed distance apart. What do you mean by this fixed distance apart? See, when you're storing data in arrays, as arrays are predefined, I mean you have to allocate the size in the program itself. That is, the size of the array can be 5 or 10 or 15 or 20. So array A1 star, for example, let's take array A1. Array A1 contains 10 elements. Next, array A2. Array A2 contains 10 elements. And array A3. A3 also contains 10 elements. So allocation for array A1 means 10 spaces, I mean 10 places in the memory. And allocation for the second array starts after this 10 places. So even these are placed at fixed distance depending on the size of the array. And your array E3 starts after 10 places. That is what is fixed distance apart. Next, it provides static allocation, which means the space allocation done by a compiler once cannot be changed during execution, and the size has to be known in advance. This is what I have said. As you work with arrays, as you have seen arrays, as you know what arrays are, we have to specify the size of the array in the program itself. So it is static allocation. It is not dynamic allocation. So the compiler should know the size of the array beforehand. It can't know it during the execution time. So the size should be known before in advance to allocate that amount of space in the memory. Next, as individual objects are stored a fixed distance apart, we can access any element randomly. Yes, the advantage in the sequential organization is, as you know where the element is stored. For example, take an array which is containing 10 elements. So what you can identify the elements in the array by the index. Yes, which a of I is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you know the value of I, which is called index, you can find out the data which is stored at that particular place easily. That is what is the end. But this is not the same with linear organization. We will see how it works in linear organization. So we can access any element randomly. Randomly in the sense, you need not check the elements, or you need not to read the elements before to that element. You can, using the index, randomly pick up any element from the object. That organization. Next, insertion and deletion of objects in between the list requires a lot of data movement. Yes, this is again the disadvantage. That you can access any element randomly. That is the advantage, and disadvantage. If you want to make insertions or deletions, the list requires a lot of data movement. So how, if you have an array of 10 elements and you have filled some 6 positions in it, you have forgotten to fill one element in between. Like after 3, 1, 2, 3, you want to put an element at the 4th place, but you have forgotten and you have filled with other elements. Now, if you want to place the element in that 4th place, what you have to do is you have to move these 3 elements by one step. Move it to the next, next, next. Then you will have a space in between where you can store the required element. And deletion also the same. If you take out one element from in the middle of the array, then you can't keep it empty. So you have to again insert it, move the objects by one step till you fill that place. So this makes the sequential organization a little bit tedious. Insertion and deletion of objects in between that list requires a lot of data movement. Next, it is space inefficient for large objects with frequent insertions and deletions. Yes, when you want to store large objects and where you don't know the size of the objects and where there is a lot of insertion required and deletion required, then in such case, sequential organization doesn't suit that particular method. So for that kind of things, you have to move to linear organization. An element need not know or store and keep the address of its successive element. Here, there is no need to store the address of the next successive element. Why? Because all these elements are packed at one single place which you can access through the index. You don't need to store the next. See, if I know the index of one element, I can find out the element at the 5th place or 6th place by I plus 1, or I plus 2, or I plus 3, like that. So if you are at 2nd place and now you want to go to the 5th place, you just 2 plus 3 is 5. Just you don't need the index value so that you can directly jump to the place. But here no need to store the address or link for the next successive element. Linked organization. So what are the features of linked organization? The features of this organization includes what? Elements can be placed anywhere in the memory. They are not needed to store at sequential places. They can be stored anywhere in the memory wherever there is place. Empty space, wherever there is empty space, you can store the elements there. Dynamic allocation. That means you don't need to know the size of the data structure or data element which you are creating at the time of creation of the program. It can be given during the execution of the program. As objects are not placed in consecutive locations at a fixed distance apart, random access to elements is not possible. Yes, as these elements are not fixed distance apart. I mean, just by adding this one number of places, you will go to that place. It's not like that. You see, I have told in arrays, if you know index I, it is 2 or 3 or 4 plus 1 plus 1 plus 1. You can go to the next position. But it's not the thing with this linked organization. They are placed randomly. So that is the reason you have to maintain the address of the next element in this linked organization. So that is the disadvantage of this linked organization. So each element has come, it should compulsorily contain one data element. I mean, each node has to contain one data element and also the pointer or link to the next node. Okay. Next, insertion and deletion of objects does not require any data shifting. This is the advantage. As we have seen in arrays or in sequential organization, there is a need to shift all the elements next. But here in linked organization, just to delete the node and you change the address of it in the previous node, enough, done, your deletion is done. Or if you insert also the same, you allocate a new node, put the data element there, take the address of the next node and put in its element and change the address in the previous node, done. It is space efficient for large objects with frequent insertions and deletions, because insertions and deletions are very easy to do. Next, each element in general is a collection of data and link. At least one link field is a must. So already I have said you, again there are types of linked lists. Depending on the number of linked fields in your node, you can decide the type. Single linked list, double linked list, circular list. So these are the different types. We will discuss them about them in later. Next, every element keeps the address of its successive element in a link field. So each node, what does it contain? Link. So what this link is? This link is nothing but the address of its successor. I mean the node which comes after this. So it will have some memory address. That address here it is stored in the form of a pointer. So this when you want to jump from this node 1 to node 2, I can draw here node 1 to node 2. Then you just go to this link and you just go to that address. You will find the second node. And here again the second node will have again element, actual data and the other link. That link points out to the third node. This is how actually the data is stored in linked list. Every element keeps the address of its successor element in a linked field. The only burden is that you need of additional space for the linked field for each element. So here the extra burden is to maintain the link for each element. But this additional space is not a severe penalty when large objects are to be stored. For small objects, it is better to store in the form of arrays. But when there are large objects, when they have to allocate the memory dynamically, then linked organization is much more suitable than sequential organization. Linked organization needs the use of pointers and dynamic memory location. What are pointers? Nothing but the links. Link field which is present in the node is a pointer. And dynamic memory allocation, because you're not allocating the memory in the program itself, that is static memory allocation. You are allocating the memory during the runtime of the program. So it is dynamic memory allocation. So this is about your linked list definition, how a linked list looks like, what is sequential organization, what is linked organization. So once you understand the differences between sequential and linked organization, What is the advantage of sequential organization? What is the disadvantage of sequential organization? And advantage of linked organization, disadvantage of linked organization. We can move to the next topic. The best example for linked list is in real life. You can see you can take the example of a treasure hunt. See what treasure hunt is, where you are first given a place or location from where you have to find out the link to the next, I mean, the address of the next place. Again, you go there, from there, you will find out the next hint, and from there, you will find out the next hint. In this way, if you solve all the hints properly without breaking the chain, then you can finally reach your destination. But if you uh, break the chain, and if you lose the links, then you may not reach the destination. So the real life example. And the other example is organizing the books in your shelf. See, if you don't have enough space to store all the 10 books at one place, then you have to store them randomly. But how will you remember which book is stored at which place? So what you will do, when you store the first book, you will write the address where the second book is stored. And with the second book, you will write where the, I mean, like in which shelf or which place third book is stored. Next, in the third place, you will write fourth book. Along with third book, you can update the address of the fourth book. When you go to the fourth place, you will go to the fifth. This is how the data is organized in linked organization, and this is how the linked lists also work. Tomorrow we will see about linked list terminology, what are the operations performed on linked list. Okay, thank you. Have a nice day.